in this talk, I'm going to cover the types of the symmetry elements, and along with that, I'm going to highlight about what is axis of symmetry in detail under this the topic molecular symmetry and the group theory. So already we know the what do you mean by symmetry element. Symmetry element is simply defined as any geometrical entity along which the operation is to be performed for getting either equivalent or identical the orientation from original orientation of a molecule. If you are getting the same, then the element is said to be, or the geometrical entity is said to be a symmetrical entity. So there are basically the five types of symmetry elements. First one is the axis of symmetry, or it is also called a symmetry axis. Second one is plane of symmetry or symmetry plane. Third is center of symmetry. Fourth one is rotational reflection axis of symmetry, and the fifth one is the identity. So we want to learn all these symmetry elements in detail. So let us see what is axis of symmetry, or it is simply called as symmetry axis, or in some book it is also called as line of symmetry or the proper axis of the rotation. So the definition for axis of symmetry is that the axis of symmetry is simply defined as imaginary line or axis within a molecule through which the rotation is to be carried out at specific angle theta to get the equivalent orientation from original orientation of a molecule. If you are along a line, if you are performing the rotation at specific angle theta, if you are getting the equivalent orientation from original orientation of molecule, then this axis is called as symmetry axis or axis of symmetry. So symbolically, it is represented by a symbol uh, Cn raised to m. Then what is n? N is called as the order of axis, or it is also called as fold, no doubt. And the n value is calculated with the help of this formula. N is equal to 360 divided by the theta. Theta is the angle of the rotation. Okay. And what is m? M is the number of times we are performing a particular element. Is number of times we are performing rotation. Is one time, two time, three time, like that. No doubt. So this n is subscript as the order of axis, or it is also fold, and the superscript, the m, is the number of times of the rotations. No doubt. Then when we take the water is an example. So water, we know that having the inverted V shape. Then this one is there are two hydrogens. So this one is H1, this is another H2. So let us consider this imagined axis passing through the oxygen atom. And if you are performing the rotation in anti-clockwise direction with the theta, means angle of rotation is 180, then we are getting this new orientation. This new orientation is uh, equivalent to that of the first orientation or original orientation. And because of the same, this axis is called as the axis of symmetry. Then what is the fold of this axis of symmetry? We know that the angle of rotation in water molecule is 180. So 360 to 180, we are getting n is equal to E2. And because of this, water has two folds, C2 axis of symmetry, C2 axis of symmetry, no doubt. And this conversion from orientation one, number one, to the orientation second, it is overall symbolically represented as C21, means one time two-fold axis of symmetry. If you are performing one time two-fold axis of symmetry on water molecule, you are getting this new orientation. And again, if you are going for two times, second time, two times two-fold axis of symmetry, we are getting the original orientation of the molecule. This is one example. Water has two-fold axis of symmetry. If you are going for ammonia, we know that this is the ammonia having trigonal pyramid geometry. And let us consider this imaginary axis passing through this nitrogen atom. Okay, if you are going to rotate this either in this direction or in this direction, if you are going to rotate in this direction, then we are getting this orientation. Or in this direction, at you are getting this orientation. If you are going to see these two orientations are equivalent to this orientation. Got out? So because of the same, the NH3 molecule has C3 axis of symmetry. Or in another words, one can say that the AB2 molecule having inverted V shape, all such molecules have two-fold axis of symmetry. If you are going for AB3 molecule having triangular pyramid geometry, all such molecules have C3 axis of symmetry. Then similarly, if you are going for BF3 molecule or AB3 molecule having triangular planar geometry, so the overall structure has like the three arm fan, no doubt. And if this BF3 molecule in one plane, then whatever the imaginary axis, this one passing through the boron, this is vertical axis, no doubt. So what is the fold of this axis? The fold of this axis is threefold. Why threefold? Because at one t rotation we are getting the equivalent or identical orientation from original orientation of a molecule, and because of because of the same, having fold is C3 fold. Along with this C3 fold, there are three C2s. Means if this in one plane and one axis passing through this BF1 bond. Let us see. So BF1 and in between this F3 and F2. So this axis having fold is C2 fold. Why 2? Because at one AT rotation we are getting the equivalent orientation. So there is exchange between these two the fluorine. There is no change in between BF1 bond. So here we are getting this is one C2, there is another C2, and there is third C2. So if you are going to see BF3 molecule having planar triangular geometry, the overall axis of symmetry as C3 plus the 3C2. Similarly, if you are going for this AB4 molecule having square planar geometry like PTCl42 minus or NiCN42 minus, all these have the square planar geometry. So this is the overall geometry for square planar molecule. Then whatever the axis passing through this let us see center passing through the A having fold is C4. Along with this one is vertical, and there are four horizontal axes. So here one passing through four C2 axis, one passing through this if there is A, this is B1, B2, B3, B4, one passing to B1, B3, and this one bond, second passing through the B2, A, B3, then this is this one third one, and there is one more fourth one. So if for AB4 having square planar geometry, the overall the axis of symmetry is C4 plus 4C2. So this set is called as D4 set. This set is called as D3 set. Similarly, if you are going for ferrocene, either having two forms, either staggered or eclipse, the overall axis of symmetry is C5 plus the 5C2s. The overall axis of symmetry is that D5 set. Then if you are going for benzene, the benzene has this vertical axis having fold is C6, and there are horizontal axes. There are 6 horizontal axes. So all these here axes are perpendicular to this one. Then overall axis of symmetry is C6 plus 6C2. If you are going for alene molecule, so this is the 3D picture of alene molecule. CH2 double bond C double bond the CH2. So in alene molecule, there are 3 axes having same pole. One axis, this is one axis passing through these 3 carbon and in between these hydrogens. Second, along if this along Z axis, then second along X axis, third along Y axis. Then if you are going to see the fold is almost same. Here is C2, here is also C2, and here is also C2. If a molecule containing more than one axis having the same pole, then among these axes which one is uh, the principal axis. So the at that time the axis which passing through the maximum number of atoms of that molecule is said to be the principal axis. So this passing through the three the carbon atoms, and because of this horizontal axis is the principal, and axis along x-axis and axis along y-axis, these are the secondary axis. And because of that, the overall axis of symmetry of alene molecule is that C2 plus 2C2. So this is this set called as D2 set. So the if you are going to see the subtypes of axis of symmetry are subclassified into two types. One is that principal axis, and second is secondary or subsidiary axis. So principal axis means axis having highest fold, and secondary or subsidiary axis means axis having uh, the lower fold than the principal axis usually. Then in this, if you are going to see the few examples already here, we know that AB two molecule having inverted V shape, like water, H2S, H2S, CO2. In all these molecules, oral axis of symmetry is C2. And there is only C2, and that acts as a principal. There is no secondary axis. In case of AB3 molecule having triangular pyramid geometry as like NS3 or PS3, the overall axis of symmetry is C3, and with that acts as a the principal axis of symmetry. Then if you are going for these AB3 having triangular planar, overall axis of symmetry is C3 plus C2. So there are two folds. One is three fold and another is the two fold. So this highest fold is the principal axis, and these are second axis. And this overall set is called as D3 set, capital 3. Then AB4 molecule, the overall axis of symmetry is C4 plus 4C2. This acts as the principal, and 4C2 acts as the secondary axis. Then AB5 molecule having TBP geometry, the overall axis of symmetry is C3 plus 3C2. C3 is the principal, and 3C2s, these are secondary axes. Then benzene molecule, overall axis of symmetry C6 plus 6C2. C6 is the principal because it is highest fold, and these are secondary axes. And in alene molecule, C2 plus 2C2 and 1C2 is the principal, remaining two the C2s are the secondary the axis. So with this I conclude the point, the axis of the symmetry.